Okay, so let's get started. Any questions on t-test, paired sample t-test, two sample t-test, ANOVA? No questions? Okay.
Sir, please repeat the ANOVA.
Okay, I'll repeat ANOVA. Um, ANOVA basically stands for analysis of variance. When you have multiple populations and you want to test if mean of all of those populations are equal, or at least one of them is not equal, then you can use ANOVA. The null hypothesis will always look like this. So it will look like mean of a particular population is equal to mean of the second population is equal to mean of the third population, and so on. The alternate, on the other hand, will always be at least one of them is not equal. There is no greater than or less than alternate here. The alternate will always be at least one is not equal. Make sense?
Okay.
Now, how do you, so if you look at the scenario here, it says that, is there any difference between segments of customers in terms of their credit card usage? Now, if you look at the segments, there were three segments, right? So you have multiple segments, which are basically multiple populations, and you want to test whether their means are equal or not, right? So this is a case to be used for ANOVA because it fits it perfectly, right? Multiple populations, you want to test whether their means are equal or not. Not means what? At least one of them is not equal, right? So this is a good case to apply ANOVA. Now, how do you apply ANOVA? What you do is you go to the stats scipy.stats module, and within that you look for this function f_one way, and then what you just need to do is pass on different data of the populations separated by comma. So here we have three segments, so we created three different data for three different segments and then passed on those data points in the f_one way. You get two things as output. One is the test statistic, second is the p-value. Here we are not interested in p-value because our alternate is not equal to. Sorry, here we are not interested in a statistic because our alternate is not equal to. The only thing that we are interested in is this statistic. Is this statistic less than 5%? Yes. What does this mean? This means that at least one of these segments has a mean which is different from the others. We don't know which segment, we don't know how many, but we know at least one. Make sense? So this is ANOVA, right? Now, moving on to the next hypothesis test that we have.
Sir, I have another
Segments
doubt.
yeah, segments are just like, you know, the type of card you have, right? Whether it's a gold, platinum, diamond, whatever.
Sir, how to identify the
We have
single?
one card. So you belong to one particular segment, right? You have a gold card, I have a silver card. So I belong to the, I belong to say segment number 1, you belong to segment number 2. Yes.
Sir, how to identify the single t-test and the paired t-test, which where it would be applied?
Yeah, I'll come to this. Sorry, you want me to go to which one? The code, right? Okay. Mm-hmm. Mm-hmm. 5%. Correct. Everywhere. Yeah, yeah. No, significance level is 5. So, okay, correct. So, significance level, there are two terminologies: significance level and alpha. Um, I don't know how to write it in Notepad. Alpha. You've seen this term alpha. So there are two terminologies here: significance level and alpha. Alpha is 5%. Significance level is 1 minus alpha, right? So when we say 5%, we basically indicate alpha. Significance level in that case is 95%. So it basically says that we are fine with a type 1 error of 5%. We are sure about it with a 95% probability, right? Alpha is what? Type 1 error. Sorry? Significance level. Confidence level and significance level are interrelated. Confidence level is used for interval estimation. Significance level is used for hypothesis testing. Is this clear? Yeah. For every test, if you are doing a two-tailed test, what you just need to do is look at this p-value. If this p-value is less than 5%, then you reject the null. If you are doing a one-tailed test, then what you need to do is look at this p-value, divide it by 2. Then you get p-value of one-tailed test. If that is less than 5%, then you reject the null. Now, since you are now converting a two-tailed to a one-tailed, you need to also know in which direction is the null rejected. Is it rejected in the less direction, or is it rejected in the greater than direction? So for that, you look at the sign of the test statistic. If sign of the test statistic is positive, it means it has been rejected in the greater than sign. If it is negative, it means it has been rejected in the less than sign. Yes, and somebody had asked me, how do we identify a single sample t-test from a paired sample and from a two sample? A single
Yes.
sample t-test, if you go back to the format that I had mentioned, so remember these three formats. These three formats will determine what test you are doing. So if you have a format which fits this means you are testing whether mean is equal to particular value for a single population, right? If you're only testing whether the mean is equal to a particular value for a single population, or is it greater than, less than, or not equal to that value, then it is a one sample t-test because you have one population or one sample to go with. If in a particular scenario you have two samples, but each observation of those two samples are basically coming from the same person or the same entity, right? Then it will be a paired sample. So for our example, what we saw was we were comparing whether the campaign was successful or not. When do we say a campaign is successful? We will say a campaign is successful if the usage of a person prior to that campaign is less than usage of the person post that campaign, right? So you see, I will have data points, two data points from each person, right? So I get a pair of points from each person, right? Two data points from each person. So therefore, I used a paired sample. Another telltale sign of a paired sample t-test is wherever you have a before-after scenario. Say if you are comparing anywhere what was happening before with what was happening now, it will probably be a paired sample t-test, right? Because in always in before after scenario, you look at the same person or as the same entity before and same entity after and detect if something has changed, right? It will always be a paired sample t-test. Two sample t-test on the other hand is clear. It will clearly tell you there are two different populations, and I just want to test whether the mean of these two populations are equal or not. If these two populations are clearly disjoint, which means that you cannot have more than one data point coming from the same entity, then it is a two sample t-test. For example, gender. If you are segmenting or differentiating the population with respect to gender, it cannot be a before after. I mean, your gender cannot change before and after, right? I mean, it can, but usually it does not, right? So, so it will probably be a two sample test, right? So it will be a two sample test, right? I mean, you will see weird things when you work on data, right? I've seen genders changing with time.
Sir, I have a question, sir. Sir,
Yeah.
in a Python code for ANOVA, you are writing one way, right? So
Right,
actually, I went for an interview last month. So they
right,
asked me a question that what is different between one way ANOVA and two way ANOVA, and how to
correct,
write a code, right? So sir, can you
correct.
just give me idea that how to identify that I have to use one way ANOVA or I have to use two way ANOVA?
No, currently we will only work on one way, right? Two-way ANOVA is something which is out of the scope. We can take it up separately outside the class. I don't want to go into two-way ANOVA with everybody, right? So it's something which you had asked. I will answer you, but outside the class, right?
Okay, okay.
Okay.
Sir, I have a
Yes,
question.
yes.
Uh, what is the difference between a stratified sample and the cluster sampling?
Okay, I'll give you an example, and that will probably demonstrate this, right? Say what I do is I want to take samples from the Indian population. What I do is I divide the whole Indian population into four parts: northern states, southern states, eastern states, western states. Four parts. I go into each of those four parts and collect 20 observations in each. How many observations do I have? 80. Okay. This is stratified sampling. On the other hand, in cluster sampling, what I'll do is I'll divide it into four parts: north, south, east, west. But I will
Mhm.
go to only the eastern states and collect 80 observations. This becomes cluster sampling.
Okay.
You have to divide because otherwise you will not be able to identify. Yeah. Do you understand?
It's clear.
Yeah. Okay.
Sir, can you
Um,
please show the code in the Python for the Z test? How to from the Z test in the Python code?
I'll show. I'll show. Z test. I'll show. Yeah. Okay. Now, moving on to let me go over these scenarios, then we'll talk about Z test. Moving over to the next one, which is the fifth scenario, just read through this scenario. Multiple paired करना पड़ेगा. There is no equivalent. There is no equivalent of ANOVA for paired sample. No. No. ANOVA you can do for two samples. That is fine. But you cannot do ANOVA for paired sample. You asked about paired, na? Okay. Correct. Correct. You could have done ANOVA also. उन्होंने पूछा था अभी. ANOVA भी कर सकते. That's fine. You were not there. Okay. Yes. Anything else? Any other questions? Because before we move on. Okay. Now, fifth scenario, right? Fifth scenario. Just read this. and then tell me if you understand what we are trying to do. All of you remember the data, right? Region was 1, 2, 3, 4, 5. Segment was 1, 2, 3.
Okay, so here we need to find the relation between the region and segment, like if in which region which segment is more popular and or less popular.
Correct.
Exactly,
So
sir.
basically what this is saying is region and segment independent of each other, or is there any dependency with each other? So for example, is it happening that in certain segments or in certain regions, certain segments are more popular, or vice versa, right? So we are basically trying to identify relationship between two variables, right? Now, if I generalize this, right, region is what type of variable? Is it categorical or is it numerical? Segment is
Categorical.
Categorical.
categorical. So in general, if you want to find relationship between two categorical variables, the test that you are going to do is known as chi-square test, right? The test that you are going to do is known as chi-square test. So the fifth scenario that we are discussing now talks about finding relationship between two categorical variables. If you want to find relationship between two categorical variables, what you need to do is a test known as chi-square test. Okay. Now, how do you do it in Python? What you first need to do is you first need to create something which is known as a cross tab, right? Let me just take you through the code, then I'll explain what this means. To create a cross tab, you need to use pandas dot cross tab. This is a function, and then you pass on two variables that you need a cross tab for. Okay, separated by comma, and then you pass on margins equal to true. Margins equal to true means it will show the totals for row and column, right? If you run this, let me run this and then I'll explain the output. The output that you get is 16 here means there are 16 observations in my data which belong to segment 1 and region 1. Similarly, there are 9 observations in my data which belong to segment 1 and region 3. Similarly, there are 45 observations which belong to segment 1. Make sense? Okay. So tell me what does this 58 mean? There are 58 observations which belong to region 3. Okay. So you understand this crosstab? To create this crosstab, you use pd.crosstab and then basically pass on the variables that you need the crosstab for. Make sense? Margins equal to true, you get the totals. If you make it false, you will not get the totals. Okay? Okay. Now, once you have created the crosstab, then in order to test, what you do is you go to stats package, which is scipy.stats. Within that, you look for chi-square contingency. Chi2 underscore contingency, right? And you pass on this cross tab that you have calculated above. Observed is the keyword. You pass on the cross tab in that keyword. As soon as you pass, if you run this, you get 4 things as output, right? Now, before we go
Observed equals to T. What signifies T?
T is here, we created T, right? Which is the cross tab.
Okay, sir. Got it.
Yeah. So I'm just passing this cross tab inside. If you run this, you get 3 things, 4 things as output. Before we understand these four things, let me give you a brief understanding how this chi-square thing works, right? What this chi-square will do is, it will look at the current crosstab, right? Current crosstab is known as the observed distribution. This is what we observe, right? That's why you see I have passed it as observed, right? Then what it will do is, it will create a distribution on its own, thinking of a scenario where these two were independent. So it will assume, what if region and segment were independent? How will the numbers look like? How will the crosstab look like? Right? If they were independent, the crosstab will look maybe look a bit different, right? So it prepares a crosstab under the scenario of independence. Then what it does is, then it compares the observed with the independent assumption. Does it make sense? So this is observed. This is known as expected. Expected means if you expect them to be independent, what would have been the distribution? It compares the observed distribution with the expected distribution. If the observed and the expected are drastically different, what does that mean? They are not independent. That means there is relationship, right? This is the independent scenario. If actual scenario is very different from the independent scenario, what does that mean? There is dependency, right?
Dependency.
Right? So what it does is, it compares the actual with the expected and then figures out whether they are significantly different or not. Make sense? Okay. Now, having said that, let's now interpret what these are. Let me start with the last one. The last output that you get is a two-dimensional array, right? This two-dimensional array is nothing but the expected distribution. Okay. Now, the
Sir, what do you
second
mean
thing
by
that
expected distribution?
expected distribution means what would have been the distribution if these two variables were independent of each other.
Okay, fine.
Next, this 9 represents the degrees of freedom of the chi-square distribution. This is degrees of freedom. Degrees of freedom will always be number of values of categorical variable 1 into number of values of categorical variable 2. 3 into 3, 9. Make sense? Okay. Why 9? Because these we talked about this, right? What is degrees of freedom? Yeah. So if in this case, if I'm only talking about these three and these three variables, how much will be degrees of freedom? There is no restriction, right? Region can take 3 values. Segment can take 3 values. Imagine these 3 are like 3 independent variables and these 3 are also independent variables. Is there any restriction that I have placed in terms of values that I want to see here? No. So what will be the degrees of freedom? 3 into 3, 9. The third output or the second output from the top that you get is actually the p-value of the chi-square test. Okay. The fourth value that you get is the value of the chi-square test statistic. Make sense? Okay. Okay. Now, to understand this, so the only thing that we are interested in is this p-value. This is the only thing that we are interested in. Now, to understand the p-value, we need to understand what is the null and the alternate hypothesis, right? So the null hypothesis in chi-square is variables are independent. Null hypothesis is variables are independent. Alternate is variables are dependent. Now, basis this, what is your conclusion? Is segment and region dependent or independent? Dependent. What is your conclusion?
They are
Dependent.
independent. They are independent because p-value is more than
They
0.
are independent.
They are independent. What do you do? What is the one thing that you need to remember from hypothesis testing?
P is
P-value
high. Yeah.
is less than 5%. You reject the null. If p-value is greater than 5%, you accept the null. So in this case, p-value is greater than or less than. So they are independent. Make sense? Okay. Now, what do you not understand from this?
But p-value is less than 5%, right?
P-value is less than 5%, is 0.55, right? So it is 5.5%.
Okay, 0.55.
Expected. Okay. Now, if you want to do this whole thing in Excel, this can also be done in Excel. What you need to do is,
Sir, I have one question in this. What is the significance of two-dimensional array here? What is the purpose of that array?
I'm coming to it. I'm coming to that.
Okay.
Okay. So if you want to do this in Excel, what you need to do is, all of you know pivot, right? Excel pivot. Okay. What I do is I create this segment here and I region here, and I count the customer IDs. So this is the cross tab. Okay. So this becomes my observed. Okay. Okay. Now I need to now get my expected. In order to get to the expected values, what you need to calculate first is something known as marginal probabilities. What is marginal probability? Marginal probability is nothing but probabilities of the margin. This is a margin. This is another margin. What are their individual probabilities? So what is the probability of this margin? 47 by 200. This is the probability of this margin, right? So what does this probability signify? This signifies probability of getting region 1, isn't it? 23% of is the probability of getting region 1. Yes or no? Do you agree? 23% is getting probability of getting region 1, right? I just divided the total number of region 1 by total number of observations. So you get probability of region 1. Similarly, I will also calculate probability of getting segment 1. Right? These are the probabilities. So you get the marginal probabilities. Now, if these two variables were independently distributed, What is the probability of getting a person from region 1, segment 1? So for example, if the probability of me getting a head is 0.5 and probability of raining today is 0.1. What is the probability of me getting a head and raining today? 0.5 into 0.1? Okay. Why? Because me getting a head and today raining are independent. If region and segments were independent, so this is segment, right? The columns are segments, right? Columns are segments. So this is segment. And these are regions. Do you follow my point? If region and segment are independent, what is probability of getting a person from region 1, segment 1?
16 divided by 45 into 16
No,
divided by 7.
0.225 into this,
0.24.
isn't it? Okay. This is the probability, right? If this is the probability, how many people will be there in this? How many people are expected to be here? This probability into 200? Yeah? You get 10.575. If you go to the expected, what do you see? 10.575. Right? This is the expected. Because here we are assuming they are independent, right? This is if region and segment were indeed independent, we will get these many people in each of the brackets. Make sense? Okay. So now you understand what does expected mean? Okay. Now, what is chi-square? What chi-square does is it calculates, if I remember correctly, I might not be right. If I remember correctly, it basically calculates sum of observed minus expected square divided by expected. This is what it calculates. Let me check quickly because I might be wrong. Yeah, so observed minus expected square by expected. Yeah. So this is what is the chi-square test statistic. So let's calculate this chi-square test statistic, right? So what we want to do is we want to calculate observed minus expected square by expected. So this is observed minus this is expected to the power 2 divided by expected, right? So I will calculate this for all possible combinations, right? Then I'll take a sum. $16.6, right? If you go back to Python, you got 16.6, right? Now, the next step is to get the right-tailed probabilities from chi-square distribution, right? So if I look at in Excel, there is a function called chi-dist. It asks for a x and it asks for a degrees of freedom. What is degrees of freedom? 9.55. What was the p-value here? 0.55. Right? So this is chi-square test. Yes. 16 is sum of this. Sum of, that's what I've written here, right? Sum of observed minus expected square divided by expected.
Sir, how you
Understand?
calculate expected? Where you got 10.575? Can you repeat again?
Yes. So if the probability of getting ahead is 0.5 and probability of me going out today is 0.5, what is the probability of getting ahead and going out?
5 into 5?
0.5 into 0.5, right?
Yes,
Okay.
yes.
So if you assume that region and segments are independent of one another, then what is the probability of getting a person from segment 1 and region 1? 0.24% into 22.5%.
Yes.
And then if this is the probability, how many people do you expect? Probability into number of observations, which is 200.
Okay. Okay.
That's how
Thank
I
you.
got 10 point. And I basically repeated it for each and every cell. This is chi-square test statistic here. Chi-dist. Again, you don't need to do it in Excel. You can always do it in Python, but this is how you can also do it in Excel. Okay. Now, there are two things to remember, right? Usually, we are only interested in the p-value. But if somebody asks you that, let's say I have gender, I have hair color, and I have skin color. Okay. If I ask you, is gender more related with hair color or is it more related with skin color?
Related with the skin color.
Nothing here. This is not a general knowledge question. Let's say if I ask you that if gender is related more with hair color or gender is related more with skin color, the way you can see or answer that question is you do two chi-square tests, right? And whichever test statistic is higher, it means they are more related, right? Higher means what? Observed and expected are more different, which means your distribution is more different from the random distribution or from the independent distribution. Make sense? Okay. Yes,
So
sir.
chi-square is always a two-tail test.
Uh, see, by default, it will get calculated in this way, right? So if you know the Python function, that should be okay. But when you go for an interview, you cannot say that the way to do a chi-square test is to write stats.chi-square contingency. That is not the correct answer. Yes, you need to. Okay. So this is chi-square test. Any question?
Chi-square test is a two-tail test.
Chi-square test is it is not a two-tail test. It is actually always a right-tail test.
Sir, the chi-square value we got 16, right? What it is telling to us? What this means?
Nothing. The only thing that it means is the higher the value, the more is the relationship, but you don't know higher until you have another value, right? So this
Okay.
test statistic on its own, if you have a single test statistic, you don't mean anything. But if you have two test statistics, you can then tell which variable is more related.
Means only p-value is important here in case of chi-square, not the chi-square
Yes.
value?
Yes, if you're doing a single chi-square test, then only p-value is important. But if you have a scenario like this, where you are doing two chi-square tests, then the test which gives you the higher chi-square basically indicates those two variables are more related.
Sir, here also we are doing two chi-square. Now we are comparing that region and
But
segment.
here, there is only this whole thing is done for only one chi-square.
Okay.
We are doing one chi-square test. We are calculating observed, we are calculating expected, and then we are calculating chi-square. This is the whole thing is one chi-square test.
Okay. So if I have other chi-square value, then I can compare and say something.
Yeah. So for example, if I ask you, tell me if gender and hair color is more related or is gender and skin color more related? Then you need to
Okay.
do two chi-square tests, right?
So
Then you can compare the chi-square value and tell me which one is more related.
so in that case, if high the chi-square means they are more related.
Correct.
Okay. Thank you.
And it will not be dependent on p-value. The higher the p-value, the more related they are.
You can also do it from p-value, but p-value is the other way around. The lower the p-value, the more is the relation.
The lower the p-value, yes. Yeah.
Correct.
Sir, in this example, gender and hair color. So first chi-square test will be between gender and the hair color, and then hair color in the skin color.
No, gender and hair color, and then gender and skin color.
Okay.
I want their relationship with gender, right? Gender is common here. So if you do chi-square test between hair color and skin color, it will basically give you relationship between hair color and skin color. I don't want that, right? I just want out of hair color and skin color, which one is more related with gender? Do you
Fine.
understand?
Yes, yes.
So sir,
Yes,
here
only for category.
p-value
Chi-square is
comes.
done only to find relationship between two categorical variables. Yes. Yes. You were saying what? P-value?
Yes. Here p-value is 5.5%. It is right tail. It comes from the function
Yes,
is
it is.
5.5.
Chi-square will always do a right tail test.
Okay, and the function always given the right tail, not that Python always give the two tail.
Always right tail.
Okay.
Yes. Anything else? Clear?
Can we use it for more than two columns?
What do you mean by more than two columns?
Like you mentioned that gender, hair color, and skin color. So
Yeah,
I
then
just,
you have multiple chi-square tests, right? So you can do it for hundreds of columns, but you have to run hundreds of chi-square tests.
can I find out, like suppose I have 10 columns, is there any relationship between the 10 columns in one go?
No.
No. Okay.
So the question was, is there any relationship between region and segment? So we concluded that there is no relationship. So in
Yes. Now
other way,
coming back to the question, here since the p-value is greater than 5%, we will say that region and segments are not related.
so can we also conclude that which segment is more unrelated to a region?
No, no, no. Segment as a whole is a single variable, right? You cannot compare anything within that. How do we? How? अच्छा हाँ मतलब ले सकते हो पर इसमें प्रॉब्लम एक है कि ये जो काई स्क्वायर टेस्ट है ना ये दिस इज गियर्ड टू डिटेक्ट डिफरेंस सिमिलरिटी डिटेक्ट नहीं कर सकते हो आप टेस्ट को उल्टा कर सकते हो what you can do is you can come up with your own chi-square function which calculates area to the left then test ulta ho jayega abhi everything the person who have written the course everybody has thought that let's do it right time that's why I said इसलिए I mean it helps if you know the logic so that you can always reverse it. So in some scenario if you need the other way, right? Instead of detecting independence, you need to detect dependence. So then you can always reverse the chi-square test. Instead of right tail probability, if you calculate left tail probability, then the whole test reverses, right? Do you understand? Right tail means what? Dependent. If I calculate left tail probability, this means what? Independent. Instead of right tail, if I calculate left tail probability, this whole test will then detect dependence. But forget about that. This is how it works. Okay.
Can you quickly summarize the Excel calculation once?
which part do you not understand?
Actually, the pivot table itself, I don't know how to create it. So probably
Oh.
that's why. Yeah.
See, this is not an Excel course, right? So I will not take you through the pivot table, but the way that you can insert a pivot table is go to insert, click on pivot table. It will insert the pivot table.
Okay.
And
So
you get
what
the
it let it be how it is created, but what is the significance of it? Can you tell that way?
significance is this, right? There are 16 observations with region 1, segment 1. 44 observations with region 2, segment 2. This basically gives me the count.
Okay, fine. Then what we did next actually, because I was just trying to figure out the pivot table. Just quickly summarize the next things that we do on
So
Excel.
next is we calculated probability of each segment and we calculated probability of each region. Right? So if there are 47 observations from region 1, what is the probability of region 1? 47 divided by total number of observations.
Right.
So I get 24%.
Yeah, margins calculations are okay. Then the rows calculation.
This one, right? So if regions
Yes.
and segments are independent of each other, then what is the probability of getting a person from region 1 and segment 1? 24% into 22%.
Right. Okay, so that is the product of it.
This is a product, and then I basically multiply with total number of observations to get the number of people, expected number of people.
Okay.
Okay, so I have the observed, I have the expected. Then I basically calculate observed minus expected to the power 2 divided by expected.
To find the chi value, right?
Then
Chi
take their
square value.
sum, get the chi-square test statistic, and then get the p-value.
Okay, fine. Thank you.
Yes. Now moving on to the list of hypothesis tests. So we are done with the 5th scenario as well, right? Now let's move on to the 6th scenario. Let's read the 6th scenario. Done? Okay. Now, what are we trying to figure out? We are trying to figure out if card usage in the latest month has any relationship with card usage prior to the campaign. Basically, we are trying to figure out if a person was using the card a lot prior to the campaign, is he using a lot of the card again till now, or is his usage gone down? That's what relationship means, right? Right? Okay. Now, what type of variable is card usage? Numeric. And in both the cases, right? So here, if I generalize this, we want to find out if there is any relationship between two numeric variables, right? Okay. To find out the relationship between two numeric variables, the statistic that we will use is known as correlation. Okay. So first what we do is copy the data. So let's copy the columns. I'll first do it in Excel, then we'll do it in Python. So copy this column. So this is pre-usage. Then we will copy usage after 2 months. So I want to see relationship between these two, right? Okay. Now, what does relationship mean? Relationship basically means if by increasing one variable, or if the value of one variable increases, does the value of the other variable decrease or increase? That's what the usage, that's what the relationship means. If with the increase in the value of pre-usage, the increase in the, if the post-usage increases, it is known as positive correlation because they basically move in the same direction. Similarly, with the increase in the pre-usage, if the post-usage decreases, it is known as negative correlation because it means they are moving in opposite direction. Makes sense? Example, with increase in age, income increases. With increasing age, your hair decreases, right? Or in some cases they do, okay? So positive correlation, negative correlation, right? Okay. How do you calculate this? So correlation as a metric, it has a mathematical expression, right? If I just give you the mathematical expression, it will be confusing. So let's understand the logic inside the expression. So what is the logic inside the correlation expression? So what we are trying to do is we are trying to basically gauge the direction, right? But direction with respect to what? Direction with is usually with respect to the mean, right? So the first thing that we are going to do is we are going to subtract the mean of a particular variable from each of its value. So first thing that we do is so let's actually do this. Let's decrease the number of observations. Right, it's easier to calculate for me. So let's say these many observations, right? Okay. So first thing that we do is pre_usage underscore. So pre-usage minus mean, right? Similarly, we will calculate post-usage minus mean. All of you are with me till here? So what I'll do is pre-usage minus average of pre-usage. I do this, and then what I do is post-usage minus average post-usage. Clear? This calculation is clear? Now, as soon as I do this, a very interesting thing happens. What is that? Half of the values become negative, roughly half become negative, roughly half become positive. Make sense? Okay. Now, understand this. If two variables are positively correlated, then a negative value here should imply there should be a negative value here as well, isn't it? Because they are moving in the same direction, right? Similarly, if two variables are positively correlated, a positive value here should indicate a positive value here. Does all of you understand this concept? Yes? Okay. If this is true, what I can do is I can generalize this as if two variables are positively correlated, then the product of these two things will always be positive, right? I can say that either both are negative or both are positive, so their product is always positive. Similarly, if two variables are negatively correlated, then a positive sign here will indicate a negative sign here, or a negative sign here will indicate a positive sign in the other side. In other words, if two variables are negatively correlated, the product of these two terms will always have a negative sign. Make sense? Okay. Now, so
Sir,
what do I do?
Sir, can you please repeat your last two lines? Positive correlated and negative
So
correlated.
if two variables are positively correlated, it means they are moving in the same direction?
Yes.
Okay. If they're moving in the same direction, then if I get a negative value in this, I should also get a negative value in this, because this is the direction with respect to the mean, right? Yes or no?
Yes.
Similarly, if they are positively correlated, if I get a positive value here, I should also get a positive value here.
True. Yeah.
In other words, basically, if I multiply these two, I should get a positive sign.
Yes.
Similarly, if they are negatively related, I will have always opposite signs on these two sides. So therefore, if I multiply them, I'll get a negative sign.
Okay. Okay. Got it.
Now, how do yes? The pre-usage mean is mm-hmm. Mm-hmm. Same way. If the mean is negative, then means most of the observations lower than mean is already negative. So if you think about it, it will exactly be the same. Same direction.
Sir, can we say in this data point distribution, we are finding, post usage mean how far or how close post usage mean is from pre usage mean, right?
No, we are not finding how far and how close. We are just looking at the sign.
I mean, as you have told the correlation, so indirectly, I think.
We are just looking at the sign right now. I'll come to correlation as a concept slowly, right? So correlation basically means I want some number which tells me how strongly are these two variables related. I want a number to tell me that. Okay. Now I am just building towards that number. So first I subtract the mean. All of you understand that if they are positively correlated, then the product should be positive. If they're negatively, product should be negative. So I need a summarization, right? So here I have a lot of observations. I need a particular number to tell me, right? A number should summarize this, right? I cannot have 20 numbers to define the relationship. So how do I summarize this? What I do is first I find the product. First I find the product. Then what is the easiest measure to summarize data? Average.
Wait.
Standard deviation is much complex. Average, right? So what I do is I take an average of this, right? If this average is high, it means high positive correlation. If this average has a negative sign to it, it means negative correlation. That's what you all agreed, right? That's what you all agreed, right? Yeah. So
Yes.
this metric, this average is known, this has a statistical term. It is known as covariance. Not that we are interested in this, but just FYI, it has a name, right? Its name is covariance, right? Now, what is the property of covariance? Covariance can vary between minus infinity to plus infinity, right? It can vary between minus infinity to plus infinity, and sign indicates direction of the relationship. Value indicates strength. Okay. So this sign, since it is a positive sign, it means that pre-usage and post-usage are positively related. And this 34 indicates the strength. But since it varies between minus infinity and plus infinity, this is a term which is very difficult to handle, right? We'll not be able to ever tell whether it is highly correlated or less correlated. Because the upper bound is infinity, right? We'll never be able to tell it's high or low. So what we need to do is we need to bind this. We need to make sure that it does not spread between minus infinity and plus infinity, but rather we need to bind this between a finite range. In order to bind this, what we do is we divide covariance by standard deviation of this variable and standard deviation of this variable, just to bind this, right? So what we do is we first calculate standard deviation of pre-usage. So calculate standard deviation of this variable, and we calculate standard deviation of post usage. Once you do that, what you then do is divide covariance by standard deviation of this and standard deviation of this. Now, this ratio that you have got is known as correlation. And what are the properties? The properties of the correlation metric is it is bounded by -1 and +1. So it will vary between -1 and +1. Its sign indicates this direction of the relationship. And the good thing is, since it varies between -1 and +1, we can express this as a percentage, right? So a 37% basically means, so if I have a 37.8 here and there is another two pair of variables which have a correlation of 32%, I can tell that this correlation is higher than this. Make sense? Okay. So now, what is correlation? Correlation is basically covariance divided by standard deviation of the two variables, right? What is covariance? Covariance is product or the average of the product of differences of each variable from their mean. Right? Sounds complex when you tell it in English, right? But you understand, right? So what we did, we calculated average, subtracted mean from each value to get the direction. Now, once we get the direction, we need to combine the direction of both variables. So we multiplied them. And then what is the easiest summarization? Average. Right? That gives me covariance. Divide covariance by standard deviation, you get correlation. Makes sense? Okay.
Sir, I have a question. I'm sorry. I mean, it's a basic one, but I couldn't able to understand it. Why you to find the product? Why you have multiply pre-uses and the post-uses? I'm sorry, I couldn't able to get it.
So I want to find relationship between these two, right?
Okay. Yeah.
Okay. So if I want to find relationship between these two, first thing that I do is I need to find the movement of the values. Movement of the values mean what I do is I need to define which values are higher than mean, which values are lower than mean.
Right.
So for that I subtract mean from each of their values for both the variables.
Right.
Okay. When I do that, what happens? The high values will have a positive sign and the low values will have a negative sign.
Right.
Okay. Now what I'm saying is if two variables are positively related, then a low value of pre-usage should indicate a low value of post-usage.
Right.
Similarly, a high value of pre-usage should indicate a high value of post-usage.
Right.
So if I multiply these two, the sign should come out to be positive always if two variables are positively correlated.
Yes.
So that's why I multiply them.
Oh, got it.
Then I have like how many? I have 15 observations. I need to summarize, right, and get a single metric. I take average.
Right. Got it.
Summing the not summing, but average. Yeah, average of the product.
So by this we can say the campaign was successful.
From covariance, you can get the direction. But if you want a percentage terms to explain how much is the relationship, correlation is better. Because correlation not only gives you the direction, this also gives you the direction, right? Correlation also has a sign. Correlation gives you both the direction and also it is a bounded value. So you can express this in a percentage. So that's why people do not typically use covariance. They will always use correlation if you want to look at relationship between two numeric variables.
So does this mean the campaign was successful because the users are
We have
increased?
not come to the campaign. We have not come to the campaign. Just a second. No. Direction will be based on the variable, right? So direction, you cannot check direction for each and every person. You have to have an overall direction. Because for me, maybe the pre-usage is less than post-usage. For you, It may be that post usage is less than pre usage, but business does not work on a single customer, right? You need the overall direction. So this gives you the overall direction. Okay, now you have got the correlation. So this is the correlation metric, right? Now, the higher the correlation, the more is the strength of the relationship. The sign tells me the direction, right? The value gives me the strength, sign tells me direction. So based on this, these two variables are positively correlated, which means if a person was spending more pre the campaign, he is also spending more post the campaign. Make sense? Okay. Now, but we cannot stop only after calculating the correlation. The reason being, the metric, the correlation that you have calculated is only based on the sample of 200 observations. You agree, right? We have only 200 observations. If we calculate correlation, it is only basis those 200 observations. But only based on 200 observations, you cannot say that pre-usage is always positively correlated with post-usage. You need to give a flavor of what happens in the population. This is based on a sample. Metric is always on a sample.
Actually, I have a question before we proceed. Can you tell me, does this value signifies that the campaign was having positive impact somehow or not?
We'll be able to tell that at the end, right? You have to watch through the whole movie to get to the end.
Okay.
So, so this is 38%, right? 38% is based on a sample. Now, before we give any input to the business, we need to be 100% sure that there is some amount of correlation in the population as well, right? Because if you tell the business that yes, we have found there is correlation, and they take some sort of decision, and if in the population there is no correlation, then they'll face a lot of loss, right? So that's why you need to give some sort of flavor of the population. So in population, how do you give the flavor of the population? You do a hypothesis test. What you do is you do a hypothesis test where the null hypothesis is correlation in population is equal to 0. This is the null hypothesis. The alternate hypothesis is correlation in population is not equal to 0. Right? We will not test for whether correlation in population is 38% or not. We will only test, is there any correlation in population? Yes or no. Okay. So this is the hypothesis test that we are going to do, right? Now let's go back to Python. So now coming to Python, the function which will give you both the correlation as well as the p-value of the test is stats dot. Within stats, you have another submodule called stats, and within that you are using this function Pearson R, right? Pearson R stands for Pearson's correlation. The function or the metric that we just calculated was developed by a statistician called Pearson and hence named after him. Okay, so this metric is actually known as Pearson's correlation, but people in general call it correlation. Okay. Now, so we are using stats.Pearson R, and within that we pass on the two variables that we want to calculate the correlation for. Okay. Now, as soon as I run this, I get two things as output. First is the value of the Pearson correlation metric. Second is the p-value corresponding to the hypothesis test that we just did. Right? First is the correlation between the two, the sample correlation between pre and post usage. Second is the p-value. Now, based on this p-value, do you think there is correlation in population? Do you think there is correlation in population?
No.
Yes. No. Okay.
Yes, there is a correlation.
So what is the null hypothesis here? Null hypothesis is there is no correlation. Alternate is there is correlation. Now, basis this p-value, is there correlation or is there no correlation?
There is a
There is
correlation
correlation,
because
right? P-value
There
is
is
less than
correlation.
5%. So there is correlation. Correlation is not equal to 0. Isn't it? Okay.
so
Independent.
we always use Pearson correlation.
Yes. Now, these two numbers combined together tell you two things. First, this tells you in the sample, based on the sample that you have had, the campaign was successful because the pre-usage, if the pre-usage was high, the post-usage is still high. Okay, that's what the first number means. The second number tells you that whatever findings you have had in the sample, in the population also, there is a high chance you have a similar finding. Because in a population, the correlation is also not zero.
So this p-value is less than 5%.
Yeah.
So we should be rejecting our null hypothesis.
Yes. That's what we have done, right? So null hypothesis is there is no correlation. Correlation is zero.
Okay, so that means there is a relation. Okay. Got it.
Yes. Okay. Clear? No. Correlation between x and y is same as correlation between y and x. Same. If you look at the function, right? Does it matter if I change the order of the columns? No, right? The covariance will still be the product, right? So it doesn't matter. A into B is same as B into A. So yeah.
So
Clear?
can we use Spearman correlation here also in same
No.
case?
I am talking about Pearson, right? So let's stick to Pearson. We'll come to Spearman later on.
Okay.
Sir, what do you mean by when P is equals to 0? We can say that relation or not relation.
Yeah. Which P are you talking about? The P value, right?
It's a P value. When the
P
P value is less than 5%, but we conclude about that correlation.
Sorry, what?
When the P value is less than 5%, but we conclude about the correlation
What is the null hypothesis?
equals to value.
What is null hypothesis?
P is equals to 0. Correlation P value is equals to 0.
Correlation P value.
Yep.
No, there is nothing called correlation P value, right? Null hypothesis is just that correlation is equal to 0. Alternate hypothesis is correlation not equal to 0. Do you understand this?
So, but we conclude about from that is the
Do you
value.
understand the null and the alternate?
Yes, sir.
Okay. Now, is this P value less than 5%?
Yes. Yes.
Okay. So in a hypothesis testing, if the P value is less than 5%, what do we do?
Except the null.
That's what is wrong now. So there is one statement that you need to remember. One single line. P value less than 5%, reject null. Reject null.
Okay.
Okay. Write it somewhere, get a tattoo, do anything. Remember this, right? P value less than 5%, reject null. Okay. So if you reject, if this is this less than 5%?
Yes.
Okay. So if this is less than 5%, what is your conclusion?
Alternate, sir.
Alternate says what?
Equals to 0.
Alternate says what?
Not equals to 0. Population
Not
is not equal to.
That means what? There is correlation?
Yeah.
Yes.
No.
So that's the conclusion.
Okay.
Okay. Please do not get confused on this, because this p-value will occur every time that you work on any algorithm. You'll always see the p-value. Okay. Okay. Now, so that brings us to the end of all hypothesis tests that we have for this course. Any question on any of the scenarios where these have to be used?
So one question. So if we want to see within a particular table that which segment
One second.
is
I'll come to the online. I'll come to the online. Sorry. The correlation was 0.66. Yes. Correct. Yeah. If the usage had, if what would have happened is, if the high pre-usage indicates low post-usage, then it would have been negative. It can vary between -1 and +1. 0 means no correlation. Anything apart from 0 means there is some sort of correlation. Sorry, what was the question from online?
So the question was, question number 5. We did any relationship between region and segment. Okay, so in that particular case, we will either conclude that whether there is a relationship or there is not a relationship. In case we conclude that there is a relationship, is there any method we can calculate that which segment is more related to a particular
No, I have already answered this, right? There is no method to calculate which segment is related and which segment is not. But this will only tell you if segment as a whole has any relationship with region.
Okay, like in earlier cases, we took individual, we did solve our questions in part, wherein we were able to test sub parts as well.
In the previous cases also, we had tested for one single variable, right?
Yes.
So here also region is as a whole is a single variable. So we are testing for that variable.
Yeah.
We will not be able to tell which value of the variable is more related with which value of the segment.
So, but out of curiosity, I'm asking that. I mean, is there any way in which this particular question can be done?
Yeah, what you can do is you can create separate variables indicating each region.
Okay.
And then do a test with the segment. You will figure.
Okay, thank you.
Sir, when we should use covariance or correlation, can you
You
fill
should
that up?
never use covariance. The only place that you should use correlation is if you want to find relationship between two continuous variables.
Okay. Covariance we will not use.
Covariance never. Yeah.
Okay.
Okay, can you go back to Excel once?
1 second. Yeah. जो अभी बोला आपने सही बोला. हाँ. नहीं, कैंपेन सक्सेस की बात ही नहीं है ना. क्वेश्चन क्या था? कैसे क्या सक्सेसफुल है? प्रॉब्लम नहीं आया मतलब सक्सेसफुल है. कैसे कैसे पता चला पॉजिटिव है? ये तो मैं पूछ रहा हूँ. से फॉर एग्जांपल सचिन ग्रेग चैपल के आने से पहले भी 100 बनाता था, बाद में भी 100 बनाता है. तो ग्रेग चैपल का कोई पॉजिटिव रिलेशनशिप है क्या इसका? हाँ. नहीं, सक्सेसफुल it does not define, right? Neither does the question ask you that. Does the question ask you that? समझा नहीं मैं. आपको आपका क्वेश्चन क्या है? हमने किया है ना अभी. ये यहाँ पे टेस्ट तो किया सक्सेसफुल है कि नहीं? नहीं टेस्ट किया तो आपको ये टेस्ट करना है ना कि whether campaign was successful or not. We have already done that test here. Huh? No, I mean, I am not saying that this question does not talk about whether the campaign is successful or not. So that has nothing to do with success of the campaign. This question is not about that. This question is just asking you, is the pre-usage related to post-usage? That's it. It has nothing to do with the campaign. Right? It does not ask you whether the campaign was successful, not successful, or anything like that. It just asks you whether the pre-usage is related with post-usage. Yes. There was a question from online. What do you want to do? I have come to this Excel.
Okay. Actually, it was something like somebody has asked in classroom because I was just looking on the values where the pre-uses is negative in the column C and D, as well as the post-uses is negative. Suppose row number 4.
Mm-hmm.
Row number 4, go to row number 4, minus 10.4 and minus 19, right? So this means after campaign, the users has even more decreased, right? In this case.
Okay.
So that way, but I think somebody has asked from the class. So this also though there is a positive correlation here, right? When one is going negative, other is also going negative. But based on such an observation, we cannot say the campaign is successful or not, because this is a negative impact rather, right?
One second. What is the question?
Yeah, I mean, somebody discussed in the class, I think. I mean, because the question is not asking for the success of campaign.
Correct. So you have nothing to talk about the success.
Right,
this is
right,
just
right.
asking about relationship.
I think it was discussed in class. I was just overhearing that. Yeah. Fine.
So one more question.
One second, I'm coming to online. अरे आपने 2 सैंपल टेस्ट किया, पेयर टेस्ट किया, इंक्रीज हुआ, इंक्रीज हुआ. छोटा प्री-यूजेस, बड़ा प्री-यूजेस, राइट? तो जो पहले से ही ज्यादा है और अभी पोस्ट में भी तो फिर जो पहले और पोस्ट मेरे को कैटेगराइज करना क्यों है? जस्ट हायर वैल्यू जो पहले भी सारा यूज कर रहे हैं या फिर जो पहले हम यूज करते थे now. But that is a different question, na? No, but that is a different question. That question has nothing to do with these 6 questions. Acha, you have a different question. Acha, how do you find if the people who are using more are still using more? No, there is no percentage. What you will do is there is a clear before after framework to do that. So what you do is quartiles पता है आपको?
Could you please repeat the question from class actually so that we can understand?
This is a separate question which has nothing to do with.
Okay.
She has asked totally a different question. So
okay.
So what you do is you define, you go to pre-usage and you define what do you mean by high, what do you mean by medium, what do you mean by low, right? And you go to post usage, you define what do you mean by high, medium, and low. No. Then what you do is you create a cross tab. Cross tab means what? There is here you have pre-categories. And here you have post categories. Okay, so we basically look at how many people move from high to high, how many people move from high to low, and so on. So you will get the number. Correct. Hmm.
Both are positive phases and both are going in the same direction, right? Both are negative, again they're going in the same direction. One is positive, one is negative.
Opposite direction.
And if this is phase means positive
Or opposite direction. Yes. There was a question from online.
Yes. So the question was, in this particular example, we took around 15 IDs and we compared the pre-uses and post-uses.
Correct.
So we compared it with a mean of that particular sample. Okay. So in this case, if a person was using higher as compared to mean, so ideally in post uses as well, if he is using higher as compared to mean, in that case, the product should be positive. Right. And the overall correlation will be 100 if both are following the same trend. But in this particular case, we got 38%. So what we can conclude with this is that the correlation is not high.
It depends, right? So high and low is very subjective, right? So you cannot say whether this correlation is high or low until you have another correlation to compare it. Say, for example, you have another correlation which talks about, say, pre-usage and post-usage after 1 year, let's say something like that. And that correlation comes out to be, say, 50%. Then you will say that this correlation is lower as compared to this. But with a single value, you cannot say whether this is high or low.
Okay. So, okay. But in an ideal case, if both the all the customer IDs are following the trend, then that should ideally be around 1.
Yeah, around 1. Right.
Okay.
Right. Okay. Any question?
Sir, I have a question regarding when to use Z-test and when to use T-test. If I remember is correctly, you mentioned that if the standard deviation is known, then the Z-test is more useful to use. Is that correct?
Yeah.
Sir, but we can calculate standard deviation anytime, right? With the data
So
set.
standard deviation, by standard deviation, I mean standard deviation of the population, not the sample.
Okay. Yeah.
That you cannot calculate.
Okay. Yeah. Thank you.
Sir, the way you teach like T-test and all, in same way we use in industry, sir?
डिपेंड करता है, मतलब आपको मैं एग्जांपल देता हूँ. जैसे एक बारी हम एक क्लाइंट के लिए काम कर रहे थे, वो क्या करता है, सर्वर बनाता है और उसको सर्वर बेचना था. तो हमारा इंटरेस्ट क्या है, सर्वर बेचे, है ना, तो अपने को पैसा मिलेगा उसके बाद. तो सर्वर बेचने के लिए एक वन ऑफ द मोस्ट इम्पोर्टेंट क्राइटेरिया इज कि आपका परफॉर्मेंस आफ्टर यूजिंग दैट सर्वर शुड बी बेटर, है ना. वन ऑफ द क्राइटेरियाज ऑफ परफॉर्मेंस इज कितना टाइम लेता है एक पेज लोड होने में. Okay, so what we did was we actually did a study where we looked at what is the average time taken for a page to load with the current infrastructure, and what is the average time taken to load a page with the server, new server. तो ये आपके पास 2 सैंपल्स आ गए. अभी आपको टेस्ट कौन सा करना है, कौन सा टेस्ट करना है, कौन सा टेस्ट कौन सा करे हुए, 2 सैंपल टी टेस्ट. ठीक है, 2 सैंपल टी टेस्ट करोगे, 2 सैंपल टी टेस्ट, पेयर्ड सैंपल करोगे,
पेयर्ड सैंपल.
अच्छा चलो पेयर्ड सैंपल टी टेस्ट करोगे, है ना. तो पेयर्ड सैंपल टी टेस्ट आपको करना है, आपको पता चल गया. ठीक है, अभी यू आर ऑन दी सर्वर, आपको सर्वर बेचना है, तो आपको आपका नल हाइपोथेसिस क्या होगा. नल हाइपोथेसिस चलो कि कोई चेंज नहीं. ऑल्टरनेट हाइपोथेसिस क्या होगा. हाँ, चेंज तो सही है, मतलब कौन सी डायरेक्शन में चेंज. हाँ, नहीं, आपका आप टेस्ट करोगे तो यहाँ पे there is a catch. So you do not need to expose, you do not want to expose your client who sells the server, है ना? What you do is you will actually test that after. So okay, let me write this down. So आपको null hypothesis तो clear है ना? Null hypothesis will always be कि pre-performance will be equal to post-performance. ये this is the null hypothesis. Now alternate के लिए आपके पास दो choice है. Alternate के बाद पास दो choice है. एक है pre is greater than post. Pre greater than post मतलब ज़्यादा time लेता था पहले, अभी कम लेता है. और दूसरा है pre is less than post, है ना? तो आप कौन सा टेस्ट करोगे?
पहले वाला
पहले वाला टेस्ट करोगे. अभी there is a risk, ठीक है? पहले वाला अगर आप टेस्ट करते हो, अगर ये फेल हो गया तो आप जो खरीदने वाला था वो तो कभी नहीं खरीदेगा, है ना? तो आप टेस्ट करोगे दूसरा वाला. तो दूसरा वाला अगर टेस्ट करोगे, अगर आप पास हो गए तो आप क्या बोल रहे हो कि मतलब अगर ये ऑल्टरनेट रिजेक्ट हो गया तो आप क्या बोलोगे? प्री इज नॉट लेस देन पोस्ट, है ना? नहीं, आप, मैं बोल रहा हूं, आप सपोज सेकंड वाला आप टेस्ट कर रहे हो. सेकंड वाला जब टेस्ट कर रहे हो दो चीजें हो सकती हैं. एक है ऑल्टरनेट आपने रिजेक्ट किया, दूसरा ऑल्टरनेट नहीं रिजेक्ट किया. अगर ऑल्टरनेट रिजेक्ट कर दिया तो मतलब क्या है कि पहले का परफॉर्मेंस अभी से बेटर नहीं है, है ना? कैसे नो चेंज? मैं बोल रहा हूं प्री लेस देन पोस्ट. इफ यू रिजेक्ट दिस, प्री इज नॉट लेस देन पोस्ट ना, तो मतलब क्या है? पहले का परफॉर्मेंस अभी से बेटर नहीं है,
राइट, अभी का परफॉर्मेंस,
है ना? तो ये दिस इज इन योर फेवर, ठीक है? अगर आप नल मतलब ऑल्टरनेट रिजेक्ट नहीं कर पाए तो आप क्या बताते हो? मैंने ऑल्टरनेट रिजेक्ट नहीं कर पाया. आप ये नहीं बोलते हो मैं ऑल्टरनेट एक्सेप्ट किया, आप बोलते हो ऑल्टरनेट नहीं रिजेक्ट कर पाए. तो बोथ ऑफ द केसेस गो इन योर फेवर. तो ऐसे आप डिसाइड करते हो टेस्ट कौन सा करना है. कोई बिजनेस पर्सन नहीं होगा, आपको डिसाइड करना पड़ेगा आपके क्लाइंट के इंटरेस्ट में क्या है, उस हिसाब से आप ऑल्टरनेट चूज करते हो. मतलब अगर हाँ हाँ नहीं, आप ये टेक्निकलिटी नहीं समझ रहे हो. आपको करना क्या है? बेचना आपको सर्वर है इन इधर केस, वो खराब है कि अच्छा है, बेचना आपको है. तो आपको बेचने के लिए करना क्या पड़ेगा? एक तो आप बोल सकते हो कि हाँ मेरा प्रोडक्ट बहुत अच्छा है. दूसरा आप बोल सकते हो हाँ मैं बता नहीं सकता हूँ कि मैं ये प्रोडक्ट मेरे से अच्छा है कि खराब है. There is only two way, right? So either you reject the alternate, which means that your server is actually doing better than the others, right? Or you say कि मेरे को पता नहीं ये मेरे से better है कि नहीं, है ना? वो डिफेक्ट ये नहीं बोलेगा कि कोई चेंज ही नहीं है. नहीं, उसका रीजन कैसा? उसका रीजन ये है कि बिकॉज देयर इज अ प्रोबेबिलिटी दैट स्टिल आवर्स इज बेटर. वो जो पी वैल्यू 5% पे खेलते हो ना, वो 5% प्रोबेबिलिटी आपको बचाता है उसमें. हाँ, आपको अपने आप लॉजिक सोचना है. करेक्ट. You will have to figure out what is in interest of your client and you will have to come up with the logic. जैसे फॉर एग्जांपल अगर क्रेडिट कार्ड यूजेज की बात होती तो क्लाइंट आपको बोलता आप मेरे को बताओ कि टोटल ये जो मैंने कैंपेन किया इससे मुझे क्या क्या इंसाइट मिल सकता है, तो यू विल हैव टू कम अप विद दिस क्वेश्चन। ठीक है, नहीं एक ही वेब पेज तो सेम है ना, सेम पेज को आप लोड करते हो दोनों सर्वर के लिए, सो पेयर्ड हो गया ना, एक ही वेब पेज से दो आता है। अलग अलग वेब पेज को करोगे फिर यू कैन नॉट कंपेयर ना। ओके, any other question from this?
I mean, from the client perspective, I just want to understand in the real projects. I mean, what is the thing that client generally looks for? Because if this is just one test, then it cannot be a. I mean, it will be a quite small project, right? How the real projects are like generally. Maybe to elaborate my question, suppose I'm from telecom background. What happens? The client will ask for end-to-end implementation of a telecom service. The customer should be able to submit the order. The order should be activated. Okay, it's too many things to be done. It takes months. But if this is just one thing that whether the campaign was successful or not, so is it like the project must not be scoped up to this statement? How exactly they are actually?
Okay, couple of things, right? In a real project, nobody will give you this data in a platter. So you will not get an Excel file with this clean data which you can analyze in a second. So first is 30% to 35% of the time will go in getting the data, right? So that is a time that will be factored into the project scope. Then the second part is you will probably not be asked whether the last campaign was successful or not. The general statement will be analyze the data and give me insight. Right? This will be the general statement. Now you have to figure out what to look for, what to analyze, and what insight to give. That's why the domain knowledge is important. So when you are really new to a particular domain, you will be paired with a person who has worked on this domain. You will not work independently. But after you get some experience, then yes.
Okay. So even in that case, they are short-lived. Like they will not be running like for years or something like that. There will be short-lived project, 3 months, 6 months.
See, no analytics project run for years. Analytics projects are usually like 3 months, 1 month, maybe 2 weeks.
Yeah.
Maximum
That is
6
what
months,
actually
right?
I wanted to know.
Nothing will run for more than a year. Certain things that do run for more than a year are basically once you have built an algorithm, they keep on testing whether the algorithm is working well or not. So that will run for year on year.
See, the season kind of projects will be like for a couple of months only.
Yeah, these will be like 15 days, 2 weeks, 1 week, maybe a day.
Take it. Okay, thank you.
Okay. Yes. Now let's do this. So yesterday we were looking at some of the assignments or some of the other questions that you guys will have to work on, right? So let's go there. And let's answer the residual of the questions. Yesterday we were looking at this, right? Okay. Cool. So here, what test did we guys discuss? Paired t-test, two paired t-tests, right? In this case, you need to do what test? Two sample t-tests. Okay. Now, then let's discuss this. Read this question. Read the third question and tell me what test will you do. Yes, first one is one sample t-test. Second? Multiple two sample t-tests, right? What you need to do is you need to do 1, 2, 3 two sample t-tests. One for fruit weight, second for seed yield per plant, third for seedling length. So first one is one sample t-test, second one is 3 two sample t-tests. Fourth.
ANOVA test. Sorry, ANOVA test.
ANOVA, right? Because you have multiple segments that you want to test whether their means are equal or not. Fifth one.
A is chi-square.
A is chi-square.
B is chi-square.
B is chi-square.
Third is also chi-square.
Two chi-squares, and you have to figure out which one has the higher chi-square test statistic value. Right?
Sir, how we are saying in fifth?
Given by unknowns or marital status.
Chi-square.
Sorry?
In fifth question, how we are saying we'll do it with a chi-square and not with a...
Because relationship status is categorical, labor force status is categorical. So relationship between two categorical variables.
Sir, the Python code for question number B, we have 2 chi-square, is similar to what we did?
Yes, you need to run 2 chi-square tests. Basically, you need to run that code twice and figure out which test gives you the higher chi-square test statistic.
Okay.
Basically relationship देख तो controlling मतलब क्या है? Relationship है. है ना? Okay. Okay. So you know what? Yes.
Sir, fifth B, the first chi-square will be between education and the
Happiness.
marital.
So which one are you talking about? B.
Fifth B, 2 chi-square, right?
Fifth C is 2 chi-square.
Okay, cool, fine. That's why I got confused.
Okay. Any question on 5? Okay. 4 के अंदर हाँ. नहीं. Rating is a continuous variable. वो देख रहे हो आप एज ग्रुप के वाइज रेटिंग डिफर करता है कि नहीं? हर सेगमेंट में you want to compare if the average rating for each segment are equal or if at least one of them is not equal. मल्टीपल सैंपल टी टेस्ट होता है. मल्टीपल टी टेस्ट करने के जगह पे आप एक टेस्ट से ये ऐसे कर सकते हैं. डिजाइन मतलब क्या है? There is only 2 variable ना, एक है सेगमेंट, दूसरा है रेटिंग. हाँ एज ग्रुप, दूसरा है रेटिंग. तो दो तो नहीं हो सकता. Okay, so all of you are clear on what has to be done, right? So when are you guys going to submit?
Sir, on third, what will be we'll be using? I'm not much clear on
third.
Third.
First one is 1 sample t-test. Second one will be 3 2 sample t-test. One to compare weight, Second, to compare seed yield per plant. Third, to compare seedling length.
Okay. Okay.
Yes. When are you going to submit? By next week?
Yeah.
Okay, next week. By next week, no? Okay. So you will need to submit this by next week, because next week you will get another assignment which is related to data analysis. Okay. नहीं data वो data exploratory analysis के ऊपर है. This is hypothesis testing.
This one is the second assignment, sir, right?
This is second assignment.
Okay.
Okay. So now let's take a 10 minutes break. After the break, we will. No. Okay. So the topic that we are going to talk about is regression. Now, before we go into regression, there are a couple of things that we need to understand prior to this. So the first thing that we need to understand is what is a model. Second, we need to understand types of models.
Sir, we can't see your screen. Can you just share it?
I have shared it actually. Can you see it now?
Yes, it is visible. I'm
It is.
able to see that.
Okay, let me just
Okay.
check something.
So types of models. Then we will talk about a concept known as bias variance trade-off. Yeah, that's about it. Okay. So these three things we need to understand before we go into regression. But having said that, these three concepts are not limited to regression. These are generic concepts which can be applied to any machine learning algorithm, right? But since we are starting with regression, before we go into this, we need to learn this. Okay, now, so the first concept is model. Now, what is a model? Model is a mathematical expression to replicate a real process, right? So it's a mathematical expression that replicates a real process. मतलब इसका मतलब क्या है? The meaning is, let's say I want to predict whether a person is going to default on a loan or not. Or let's say I want to predict, given the features of a car, how many cars will I sell, right? So these, you see, if you look at these scenarios, these are complex real scenarios, right? And there are a lot of factors. Okay, so Vikas, what is this one hot encoding? Randomly Google पे search करके ping करते रहे. Sorry?
I didn't search. I know this means this is required in regression.
We'll come to it, right? Not right now. So mathematical expression to replicate a real process basically means you are trying to basically understand mathematically what governs something, right? Say for example, what governs or what makes a person default in a loan. Default means he's not able to pay back, right? Or what governs how many cars will sell, right? So you try to understand that or try to replicate that using a mathematical expression. That expression is known as a model, right? Now, models can be of two types. One type of model is interpretable. / visible, and then you have black box. Okay. Interpretable or visible models are ones for which you can actually see the mathematical expression, right? Whereas black box are the ones for which you do not see the mathematical expression. The mathematical expression is too complex, too big to see, right? Or to manually interpret anything out of it, right? So model is a mathematical expression. It can be of two types: A, simple, interpretable or visible; B, black box. Okay, we will understand and study different types of models which belong to either A or B, right? And we will understand also when to use what. So this is all about what is a model. Now, then let's look at types of models. Types of models are basically of the following types: supervised, unsupervised, semi-supervised, reinforcement. The spelling might be wrong in case of reinforcement. Okay. Okay. Now let's start with supervised. So what is a supervised model, or what is that scenario when you use these models? Now imagine, as a data scientist, you have a toolbox, right? It's known as data scientist toolkit, right? Now that toolkit has a lot of drawers, right, which you can draw up, right? Whenever you draw upon a particular drawer, each drawer is basically equipped to handle a particular set of scenarios, right? So imagine like any toolkit, right? For some jobs you need a pliers, for some job you need a screwdriver, and so on, right? Data scientist toolkit is very similar. Different drawers for different types of problems. Each drawer will have multiple tools inside it. For example, the drawer which has a screwdriver might have screwdrivers of different shapes and sizes. So similarly, in the data scientist toolkit also, you have different drawers which have different algorithms. All of them geared to do the same job, but some of them have certain advantages, some of them have certain disadvantages. Make sense? Okay. Now, so supervised, unsupervised, semi-supervised, and reinforcement are those drawers, right? Within these drawers, there are multiple algorithms to tackle each of these scenarios. So first, let's start with supervised. So when do we open this supervised drawer? We'll open this supervised drawer when we want, or when we basically know what to predict. When we know what to predict, then we will use this supervised set of techniques, right? For example, let's say I want to predict whether a person is going to default or not. I know what to predict, right? Let's say I want to predict how many cars will I sell. I know what to predict, right? Let's say I want to predict whether a person is going to buy a product or not. I know what to predict, right? In all of those cases, we will use some form of a supervised learning algorithm. Okay. Now, supervised is clear. Basically, you know what to predict. Unsupervised. Unsupervised is we do not know what to predict, right? When we do not know what to predict, we will use an unsupervised learning technique. Example, let's say I just want to categorize my customers into groups. I do not know what are those groups, right? I do not know those groups, but I want to figure out how many groups or what customer will go into which group. I don't know the definition of the groups, right? That is unsupervised. You are somewhat predicting, but you do not know what to predict, basically. You are right. You are predicting which customers are very similar. The data. So that's what here also you are going according to the data. If you can call this as predict, why can't we call this as predict? Example is, let's say, I do not know how many types of people are in this room, right? Because I don't know what are those types, right? But I know that not all of you are similar. What I need to do is I need to create groups. Why do I need to create groups? I need to create groups so that I can deliver this course customized to different groups. So for now, I'm delivering it in a very generic way so that everybody understands. But let's say we are doing it online, right? Where there is a possibility of customization. Then what we can do is, if we can detect different types of participants, we can have the course delivered in different ways. Maybe people with strong programming background, we will make it more programming intensive. Maybe with people with some sort of mathematical background, we'll make it more mathematical, and so on. So if you know your types, you can customize your service. Make sense? Second, what are the other applications? Other applications is if you want to reduce the size of a picture. Let's say you have a picture which is composed of pixels, right? Now, if you send the picture as a whole, every pixel gets communicated, isn't it? So if I mail a picture to you, you get every pixel from my computer to your computer. But let's say I don't want to use that much of data, but rather I want to compress the picture. What I will do is I will basically find out which pixels are similar to one another and group them into a single place. So what happens, instead of say thousands of pixels, what goes is 5 to 6 groups. And when it reaches your computer, there is a reverse algorithm which then can convert those groups to individual pixels. It is possible. You will understand how, but in some time. Okay. So this is unsupervised. Basically, you do not know what is why, you do not have any why, you just want to group similar observations. That is unsupervised. Next, semi-supervised. Semi-supervised is where we know the why, or we know what to predict for some observation, but not for all, right? So let's say you know what to predict for some, but do not know what to predict for all. What you will do is you will use a semi-supervised algorithm. Example, a very real example was is basic of semi-supervised learning is an experiment which was done by Google when it was initially launched. So what you have to understand is when you search in Google, say if I search machine learning, Google has to figure out which web pages are talking about machine learning and which web pages are not talking about machine learning, right? Now, basically it's a supervised learning algorithm, right? You know what to predict. You are predicting whether it is talking about machine learning or not talking about machine learning. Makes sense? But it was not supervised in the beginning. Why? Because when Google launched, the websites were not indexed. Indexed means nobody knew which website was talking about what, right? Nobody had indexed it. Now it is indexed, but not back then, right? So what they had to deal with is they had to somehow figure out how to index it, right? So what they did was you had thousands of websites. They manually sat and manually indexed hundreds of websites. They basically hired few college graduates and they manually sat through and indexed what each website was talking about, right? Huh? Manually, yeah. So hundreds of websites were indexed. So now what you have is, so if you have indexed those hundreds websites, let's say they have indexed 100. So total number of websites, maybe one, not back then, but maybe say 100,000, right? Back then it would probably be 100,000. Okay. How many have you indexed? 100, right? So you know what to predict for 100, but for rest 90K something, you do not know what to predict. And in that scenario, they used an algorithm which belongs to this family, which is semi-supervised. Okay. So it's a mixture of supervised and unsupervised. That's why the term semi-supervised.
So can you give any other example?
Not that I know of, right? So another example will be in credit rating. Often, so we work with this financial small bank which was starting out, right? So the bank was working in a sector which has never been worked on. So what they was doing is, say you want to buy something in Amazon, right? And you do not have the money right now. What you can do is you can get a loan from them in 30 seconds and use that to buy. So this is a sector on which no other bank had worked on at that time, right? So you do not know which kind of people will default under this kind of product. So you did not know what to predict, right? So under that scenario also, we used a semi-supervised algorithm. Okay. Yeah. Reinforcement. Reinforcement is basically a very new field which has come in. So here we know what to predict, but there is a delay in getting to it. Say for example, let's say you are designing an algorithm which can play chess, right? Now, the outcome of any chess match is basically two. Either you win or you lose, right? Or you draw, right? Say three. But you do not come after one single move. The outcome is basically a combination of hundreds of moves, isn't it? So if I want to design an algorithm that can play chess, I'll have to go to reinforcement learning because I know why, but it comes with a delay in time, right? Or for example, if I want to design a self-driving car, right? I want that car to go from here to another place. Now, the outcome of this is either you reach that place or you don't. But you do not reach that place by taking a single left turn. No, you have to take a lot of left, right, and henceforth to reach that particular destination or not reach it, right? So then also we will use a reinforcement algorithm, right? So reinforcement algorithm is basically a supervised algorithm, but here you only know the value of what you have predicted after a time delay. Say if I take a left, whether I reach my destination or I do not reach my destination, I will know maybe after 1 hour, right? So there is a time delay. Now, for this course, we will only be talking about these two. Okay. So for you, what you need to learn is what is supervised and what is unsupervised. Make sense? Okay. Now tell me, is these two concepts clear? Interpretable is basically a subtype in each. So interpretable and non-interpretable are features of a particular algorithm. And these are broad business problems. Now, let's move on to the third concept, which is bias variance trade-off. Now, to understand bias variance trade-off, two things need to be understood. What is bias and what is variance? Bias is another English word to basically talk about error, or in the other words, accuracy. But it's basically an antonym for accuracy, right? It's opposite of accuracy. Okay, now let's talk about this in detail. So when I say bias, think about why are we building any model? So we are building any model to actually predict something, right? Or to actually quantify something. Ideally, we would like our model to be very accurate, right? That's why you build the model, right? You want this to be very accurate, or in other words, you want to have a model with low error, right? Now, what is error? Error is nothing but actual minus predicted, right? This is error. What was the actual outcome? What is it that you said and their difference? That is the error, right? So we want this thing to be as low as possible. Do you agree? Right? So for example, if I'm predicting sales of a car and if the actual is say 10,000, I want my predicted to be as close to 10,000 as possible, right? So we want this thing to be as low as possible. Now, in today's world, the algorithms are so good at minimizing this thing, right? The algorithms are so good in minimizing the error that we often encounter a problem known as overfitting, right? The algorithms are so good that they overlearn the data. So one example, one very intuitive example, which I often take to explain this. So there are two concepts that you need to understand: overfitting and underfitting, right? So what is the intuitive way of explaining this? What is overfitting and what is underfitting? So when we were studying in college, so I studied a subject which is very mathematical. I studied basically statistics. So it's very mathematical. So there were three kinds of people, right? One like us who never studied, right? Two, there were second kind of people who used to literally mug up the mathematics, right? You cannot mug up the mathematics, right? Three, there were people who actually understood the logic, right? Three kinds of people. One like us who never studied, two who mug up, three who understood the concept. Now come the exam day, right? Come the exam day, what happened to the people who mugged up? If the questions were exactly the same, their accuracy was 100%. If one single factor in the question changed, their accuracy was 0. Do you understand? Right? Okay. Second, what happened to the people who did not study? No matter what question came, they were always getting low marks, right? Third, people who actually understood the concept, they scored high irrespective of what was the question. Make sense? Okay. The first case is known as overfitting. Second case is known as underfitting. Third case is optimal fitting. So overfitting is a scenario when your model has learned the data so well that it is not able to generalize. So you have to understand, when you are building a model, you are building that model on a sample of data. You cannot build the model on the whole world population, right? And when you build the model, you expect the model to perform well outside that sample of data. Make sense? That's why you are building the model, right? You are building the model on a data which you have, and you expect that model to work for any other data point, right? So you basically may want that model to understand the basic concepts that exist in the data. But if these days the algorithms are so powerful that they will understand more than what is required. They will try understand patterns which only exist in that data. Say for example, let's say I have a data where I am trying to predict, say, gender, right? Based on height and weight, right? Let's say in my data, let's say I have 3 variables, right? So I'm predicting gender based on height, weight, and hair color, right? 3 variables. So what in my data, what I have is, I have one person who has a blonde hair color, and that person is incidentally a female. If my model has overfitted, what it will do is, whenever it encounters a blonde, it will by default categorize that person as female. Whereas in the population, that may not be the case. This is an example of your model learning patterns which are specific to the data that you have, right? So I can only deal with a small amount of data, right? I cannot have the whole world population with me. In my population, incidentally, there was one person with blonde hair color, and that person was female. That was unintentional, right? But the model learned that, and every time a blonde comes in, that person will be predicted as female, right? So this is known as overfitting. Overfitting is basically learning patterns that are specific to the sample used to build the model, right? Understood overfitting? Okay. Now, underfitting. Underfitting is you were not able to learn all the patterns, right? Simple. I mean, your model was not good enough to learn the obvious patterns, right? So your model not able to learn obvious patterns. And optimal fitting is model can be generalized, right? Model can be generalized into any data outside the development data. Okay. So these are the 3 concepts that you need to learn. Now, coming back to the bias variance trade-off. What is bias? Error, right? What is variance? We'll talk about that. Now, out of these 3 things, where do you want your model to be in? Optimal fitting. So when you have optimal fitting, your model should have low bias in the data that you use to develop the model, as well as low bias in the data outside that data, right? Okay. Now, how do we measure whether a model is overfitting, underfitting, or it has fit optimally? How do we measure that? What we do is, there are 2 ways of measuring this. One is known as development validation split. Second is known as k-fold cross validation. It's written as k-fold X validation, but it's k-fold cross validation. Okay, now let's start with development validation split. Now remember, what are we trying to figure out? We are trying to figure out whether our model is overfitting, underfitting, or is it fitting optimally. This is what we are trying to figure out. Now what we do is, when developing the model, if you want to do this development validation split, what you will do is, after you have got the data, you will split the data into two parts. Right? Usually you split it into 70-30 ratio. Right?
Training and
Split it into 70-30 ratio. 70% of the data will be used to build the model. 30% of the data will be used as a validation of the model. Right? So what we do is, we split the total data into two parts. 70% of the data will be put into a part known as development data. 30% of the data will be put into a part known as validation or testing data. Right? 70% development, 30% validation or testing. What you do is, you develop the model on this 70% of the data. Right? And then you calculate the error on the development data. Right? Let's say that error is error 1. Then what you do is, the validation data that you have, you use your model to predict the outcome for the validation data as well. Right? You use that model to predict outcome for the validation and then measure the error on validation data. Let's say that is error 2. Make sense? Okay. Okay. Now, what you do is, you then calculate something which is known as bias. Bias is basically average error. And variance is basically variance of the error. You calculate average of the error. You have two error numbers. You calculate their average and you calculate their variance. You understand variance, right? It's square of standard deviation. Now, once you have calculated these two, tell me, how do I detect overfitting or underfitting or optimal fitting using these two numbers? No, it's on the same.
Variance of the error is in the positive side of the average error.
Variance is a square. Variance is a square number, so it will always be positive.
It will always.
Okay, so you will say that it is overfitting if the bias is really low and the variance is very high, right? Why do I say that? So what is overfitting? That means what? Error will never be zero. Correct. So this error that you calculate on the development data, right? Now going back to the example that I gave, right? This error that you are calculating, this is like scoring on the same chapter that you have just read, right? If you have marked up that chapter, how much will be your accuracy? 100%? Okay. Now, This error on the validation data, this is scoring on a different chapter. If you have marked up the previous chapter, how much will be your accuracy here? 0. Error will be high. Okay. Now, if you have really marked up the chapter, if I calculate the average value of the error, it will still be low. Right? Because in one case your error was 0, in the other case it was high, average still low, right? But the variance will be very high because the scores are very different. Makes sense? In one development data, your error is probably close to 0, whereas in the validation data, your error is high. The average value will still be low, but the standard deviation or the variance will be very high. Makes sense? Okay. So a telltale sign of overfitting is low bias and high variance. This is a telltale sign of overfitting. Low bias, high variance. Make sense? Okay. Now, let's talk about the people who did not study at all, right? If you score them on the chapter they were supposed to read, how much will be the score? Low. If you score them on a different chapter, how much will be the score? Low. So the average score will be low, but variance will also be low. Because if both of them they scored bad, right? Their difference is not that high in terms of score. Now, coming to this, if your algorithm is underfitting, how much will this error be, high or low? High here. So the average value is high, standard deviation low. Okay. So a telltale sign of underfitting is high bias, low variance. Make sense? Now, let's say we are scoring the people who have actually understood the concept. If you score them on the same chapter, how much will be the score? High. If you score them on a different chapter, you also expect them to score high. So the average score will be high. Standard deviation low. Because in both of them they scored high, right? So the variance is not that high. Now, if your model is optimally fitting, error 1 will be low. Error 2 will be low. So a telltale sign of optimal fitting is low bias and low variance. Tell me whether you understand these 3 lines.
Okay, sir.
Yes.
So in case of overfitting, what the logic is that repeatedly we are getting the same number. That means bias is low, but the actual answer is different. That means variance is high. So is that
What do
correct?
you mean by same number?
I mean, it is overfitting. That's why we are getting nearly the same result. So bias is low in case of getting the output.
Overfitting basically means in the development data, your error will be very low because it has learned the development data really well. On the validation data, your error will be high because here the same patterns might not be present. But when you take bias, which is average of these two values, that will still be low because error 1 was really low, right? So if you average a very small value and a medium high value, you get still a small value, right? So your bias will still be low, but the variance will be very high. Variance will be high because error 1 is very different from error 2. So the variance will be very different. Now, instead of calculating all of the error bias and the variance, what often people do is there is a thumb rule. What is that thumb rule? Thumb rule says that if your error differs by 10% of its value in development data when tested on validation, then there is a problem. right? What we'll do is we will build the model on the development data, get the accuracy on the development data, right? Let's say, let get the error on the development data. Let's say error is 10%, right? If when we apply this model on the validation data, the error that we get, if that error is, if that error differs from the development data error by 10%, then there is a problem. So if the development error was 10, if my validation error is anything lower than 9 or anything higher than 11, then there is a problem. Error 1 and error 2 is going to be high. Yeah, error 1 and error 2 are both high, therefore high bias, but the variance will be low, right? Both of them will be high values. तो मतलब फॉर एग्जांपल ले लो आप let's say there are 3 person, right? 3 लोग हैं. एक बंदे का नाम है ओवरफिटिंग, एक का नाम है अंडर फिटिंग, एक का नाम है ऑप्टिमल. ठीक है. ओवरफिटिंग जो बंदा है वो क्या करता है, हर चीज को ना एकदम बाय हार्ट वो रिमेम्बर करने की कोशिश करता है ना. अंडर फिटिंग क्या करता है, वो पढ़ता ही नहीं है ना. और ऑप्टिमल क्या करता है, ऑप्टिमल कॉन्सेप्ट समझता है, ये अच्छा बंदा है ना. ओवरफिटिंग क्या होगा, सपोज एक चैप्टर आपको पढ़ने के लिए दिया था, ओवरफिटिंग तो बाय हार्ट पढ़ लिया उसको, तो उसको ये चैप्टर पे टेस्ट करो, उसको स्कोर मिलेगा 100, है ना. अंडर फिटिंग को क्या मिलेगा, 0, पढ़ा ही नहीं है ये. ऑप्टिमल को भी 100 मिलेगा. ठीक है. अभी जो टीचर थे उसने क्या किया है, चैप्टर 1 से क्वेश्चन किया है पर ना नंबर्स थोड़े बदल दिए, क्वेश्चन थोड़ा ऊपर नीचे कर दिया है. तो ओवरफिटिंग क्या करेगा, वो उसको तो पता है फर्स्ट क्वेश्चन का आंसर ए ही होना है, कुछ भी आए, है ना. तो उसको तो मिलेगा 0, है ना. अंडर फिटिंग को कुछ फर्क नहीं पड़ता है, उसको 0 ही मिलना है. और ऑप्टिमल को तभी भी मिलेगा 100. ठीक है. अभी आते हैं 2 कॉन्सेप्ट पे. अभी एक कॉन्सेप्ट है बायस, दूसरा कॉन्सेप्ट है वेरिएंस. ठीक है. जो ओवरफिटिंग है उसके लिए बायस क्या होगा, बायस लो, एवरेज ले लो ना, तो उसको 50 तो दोनों एग्जाम मिला के 50 तो मिल ही गए, राइट. सो बायस विल बी लो, राइट. पर वेरिएंस क्या होगा उसका, एक में 100 मिला है, एक में 0 मिला है, वेरिएंस बहुत हाई होगा ना उसका, तो वेरिएंस हो गया हाई. ठीक है. नेक्स्ट आते हैं अंडर फिटिंग पे. अंडर फिटिंग के लिए बायस क्या होगा, बहुत हाई, तो 0 ही मिला है. वेरिएंस क्या होगा, पर वो कांसिस्टेंट है, 0 हर बार स्कोर करता है ना. तो वेरिएंस उसको मिलेगा लो. ठीक है. ऑप्टिमल जो है वो अच्छा है, वो हर बार 100 पे 100 मारता है, उसका बायस भी लो है, उसका वेरिएंस भी लो है. ठीक है. अब बताओ समझ में आया? हाँ हाँ. अच्छा, ये स्कोर इज एक्यूरेसी. ठीक है. इसको उल्टा कर लो. लेट्स से यहाँ पे हम मानते हैं कितना मार्क्स उसको मिला नहीं है, ये उल्टा हो जाएगा ना. फिर इसमें कितना मार्क्स चैप्टर 1 में मिला नहीं है, 0, ये हो जाएगा 100. सिमिलरली यहाँ इसको तो 100 ही 100 दोनों में मिलेगा, और इसको 0 0 दोनों में मिलेगा. हाँ ठीक है. ओके. ये समझ में आ गया. नाउ अभी आप जब मॉडल बना रहे हो आपको
Sir, I do have a question.
सॉरी या
error differs by 10%. How we can calculate the 10%?
अच्छा, okay. Now let's now ये जो concept है ना, ये थोड़ा मतलब discretionary, मतलब it is very subjective, right? मतलब आप कितने बायस को हाई बोलोगे, कितने को लो बोलोगे, राइट? ऐसा कोई तो नहीं है ना, मतलब हाउ मच वेरिएंस शुड यू कॉल हाई और हाउ मच वेरिएंस शुड यू कॉल लो। तो लोग क्या करते हैं, एक थंब रूल बना लिया है। ये थंब रूल है बाय द वे, देयर इज नो साइंटिफिक बेस टू इट। थंब रूल क्या है, अगर सपोज आपका जो एरर है इन डेवलपमेंट डेटा, एरर व्हाटएवर इज द एरर, उसका वैल्यू आया 100, ठीक है, और एरर जो आपके वैलिडेशन पे आया उसका वैल्यू है 120, है ना? तो आप क्या कैलकुलेट करोगे, एरर वैलिडेशन डिवाइडेड बाय एरर डेवलपमेंट। अगर ये जो इंडेक्स है ये 1.1 से ऊपर गया या 0.9 से नीचे गया तो कुछ गड़बड़ है, ठीक है? एरर 10% से ज्यादा ऊपर नीचे नहीं होना चाहिए। अगर हो रहा है तो देन देयर इज अ प्रॉब्लम। है ना? 10% ऊपर नीचे, 10% नीचे गया मतलब 0.9 से नीचे, 10% से ज्यादा ऊपर गया मतलब 0.1 1.1 से ऊपर गया, ठीक है? ओके, नाउ एनी अदर क्वेश्चन ऑन दिस कॉन्सेप्ट?
Sir, in a development data, you are calculating the error, which you said, let's suppose 100. So how you get 100 error? I mean theoretically I understand, okay, that is error.
हाँ, अभी एरर नंबर आप छोड़ दो, नंबर ले लो, ऐसे मिला है।
Okay,
अब कॉन्सेप्ट समझ लो, नंबर पे हम आएंगे।
Okay, cool.
कॉन्सेप्ट समझ में आया थोड़ा? ओके, अभी अभी ये समझते हैं इसको ट्रेड ऑफ क्यों बोलते हैं। हम, हमारा सब्जेक्ट क्या था, बायस वेरिएंस ट्रेड ऑफ। आपको बायस क्या है पता है, वेरिएंस क्या है पता है, ओवर फिटिंग, अंडर फिटिंग, ऑप्टिमल फिटिंग पता है। अभी ये समझते हैं इसको ट्रेड ऑफ क्यों बोलते हैं। ट्रेड ऑफ इसलिए बोलते हैं क्योंकि प्रॉब्लम क्या है कि ओवर फिटिंग और अंडर फिटिंग के बीच में एक बहुत थिन लाइन है जिसको बोलते हैं ऑप्टिमल फिटिंग। ये अचीव करना बहुत डिफिकल्ट है। मतलब क्या है, आप सपोज एक एग्जाम के लिए पढ़ रहे हो, नहीं पढ़ो तो पास नहीं करोगे, ज्यादा पढ़ लिया तो भी पास नहीं करोगे, है ना? तो कितना पढ़ना चाहिए, दैट इज अ ट्रेड ऑफ ना, आपको कितना पढ़ना चाहिए। तो दैट्स व्हाई दिस इज अ ट्रेड ऑफ, बिकॉज इफ यू कीप ऑन रिड्यूसिंग द बायस योर वेरिएंस विल इंक्रीज, इफ यू कीप ऑन रिड्यूसिंग द वेरिएंस योर बायस विल इंक्रीज। सो वो जो थिन लाइन होता है उसको ट्रेड ऑफ पॉइंट बोलते हैं। समझ में आया आपको क्यों होता है, क्यों इंक्रीज होता है? यू अंडरस्टैंड राइट? इफ आई कीप ऑन रिड्यूसिंग माई बायस, मतलब अब मैं क्या कर रहा हूँ, मॉडल को जबरदस्ती और लर्न करा रहा हूँ, और लर्न करा रहा हूँ, तो क्या होगा, मेरा बायस तो कम हो जाएगा, मेरा वेरिएंस बढ़ जाएगा क्योंकि मॉडल जनरलाइज नहीं हो पाएगा। सेकंड, मैंने मॉडल को लर्न ही नहीं कराया तो क्या होगा, मेरा वेरिएंस तो कम रहेगा पर बायस बहुत हाई हो जाएगा। इस दोनों के बीच में एक लाइन है जिसको ऑप्टिमल फिटिंग बोलते हैं। तो दिस होल थिंग इज अ ट्रेड ऑफ बिटवीन whether you should increase the bias or you should reduce the variance. Make sense?
Sir, means variance increase करेगा, that number of attempts बहुत ज़्यादा आपने मॉडल को लर्न करवाने में लगाया, so that's why variance will.
अगर आप बहुत ज्यादा पढ़ लिए, मतलब मॉडल को इतना ज्यादा लर्न कराया कि वो बहुत स्पेसिफिक हो गया उस डेटा सेट पे, तो आपका बायस तो लो रहेगा, मतलब ओवर फिटिंग हो जाओगे आप, बायस लो रहेगा, वेरिएंस हाई हो जाएगा। अगर आप बिल्कुल नहीं ट्रेन किया तो बायस तो लो रहेगा, सॉरी बायस तो हाई होगा, वेरिएंस लो हो जाएगा। उस दोनों के बीच में एक पॉइंट है जिसको ऑप्टिमल बोलते हैं।
अंडरस्टैंड?
ओके, नाउ एनी क्वेश्चन ऑन दिस? ये कॉन्सेप्ट ना बहुत इंपॉर्टेंट है क्योंकि बाद में ना हम इसको बार बार यूज करेंगे। ये कॉन्सेप्ट समझना बहुत इंपॉर्टेंट है। डेवलपमेंट डेटा मॉडल हमेशा डेवलपमेंट डेटा पे बनेगा। 70 या 80% डेटा आप डेवलपमेंट के लिए रखोगे, उस पे मॉडल बनाओगे। आप लोगों में से बहुत लोग सॉफ्टवेयर बैकग्राउंड से हो ना, सॉफ्टवेयर बैकग्राउंड में भी ऐसा होता है ना, आप ज्यादा टाइम किस पे लगाते हो डेवलपमेंट के लिए, फिर उसको कुछ टाइम तक टेस्ट करते रहते हो,
Right.
ताकि
Then
वो
UAT then
प्रोडक्शन में जाने से पहले वो रेडी हो जाए, है ना।
Right.
तो ये भी मॉडल पे भी वैसा होता है, आप बना लेते हो फिर उसको टेस्ट करते हो। Okay, now the other mechanism for doing this bias variance trade-off is k-fold cross validation. K-fold cross validation में क्या होता है, आप अपने डेटा को let's take a value of k को एक वैल्यू दिया जाता है, यूजुअली 10 दिया जाता है, इसको बोलते हैं 10-fold क्रॉस वैलिडेशन। 10-fold क्रॉस वैलिडेशन में आप क्या करते हो, आपका जो डेटा है उसको आप इक्वल 10 टुकड़ों में तोड़ते हो, ठीक है। तो लेट्स टेक एन एग्जांपल। लेट्स से आपके पास 10 ही लाइन का डेटा है, ये 10 लाइंस हो गए, दीज आर ऑब्जर्वेशन नंबर, इसके बाद कुछ वैल्यूज होंगे पर फॉरगेट है। आपके पास 10 लाइन का डेटा है, मैंने क्या बोला, आप अपने डेटा को 10 इक्वल टुकड़ों में तोड़ोगे, तो हर ऑब्जर्वेशन एक एक टुकड़ा बन गया। ओके, अभी आप क्या करोगे, आप आइटरेट करोगे 10 बार। पहले आइटरेशन में आप क्या करोगे, आप 90% ऑफ योर डेटा को डेवलपमेंट के जैसे ट्रीट करोगे, जो 1/10 डेटा रहेगा उसको वैलिडेशन जैसे ट्रीट करोगे। हो गया एक आइटरेशन। सेकेंड आइटरेशन में आप क्या करोगे, आप इस पोर्शन को डेवलपमेंट के जैसे ट्रीट करोगे, इसको वैलिडेशन बनाओगे। थर्ड आइटरेशन में क्या करोगे, आप ये दो पोर्शंस को वैलिडेशन डेवलपमेंट के लिए ट्रीट करोगे और वाइड वाले पोर्शन को वैलिडेशन बनाओगे। This will continue 10 times till every part has been used as validation once. है ना, 10 टुकड़ा है, एक एक बार वो हर टर्न मिलेगा हर को वैलिडेशन बनने के लिए।
Sir, what do you mean by validation here? Means we will test on that particular data.
हाँ, या आप मॉडल बनाओगे 9 ऑब्जर्वेशन पे, 10 पे टेस्ट करोगे, यहाँ पे 2 to 10 पे मॉडल बनाओगे, फर्स्ट पे टेस्ट करोगे एंड सो ऑन, ठीक है। तो
सर ये 80-20 रैंडमली होता है?
हाँ सॉरी,
ये 80-20 70-30 में रैंडमली डिवाइड करेगा डेटा को, या वन टाइम बेसिस?
70-30 वाला सीन नहीं है ना, ये 70-30 वाला खत्म हो गया, अभी के फोल्ड क्रॉस वैलिडेशन है। के फोल्ड क्रॉस वैलिडेशन में टोटल डेटा को आप के पार्ट्स में तोड़ोगे, यहाँ पे मैंने 10 लिया है। पहले k-1 पार्ट पे मॉडल बनाओगे, kth पार्ट पे उसको टेस्ट करोगे, एंड दिस विल गो ऑन फॉर k टाइम्स till every of those k parts has become your validation at least once.
Okay, k times and k parts.
हाँ, तो इसमें क्या होगा, हर एक आइटरेशन पे आपको एक टेस्टिंग एरर मिलेगा या एक वैलिडेशन एरर मिलेगा ना हर पार्ट में। तो यू हैव एरर 1, एरर 2, एरर 3, सो ऑन, एरर 10। 10 फोल्ड क्रॉस वैलिडेशन कर रहे हो तो 10 एरर मिलेंगे, है ना। बायस इज एवरेज ऑफ दिस एरर्स, वेरिएंस इज देयर वेरिएंस, ठीक है। ये मिल गया बायस और वेरिएंस, इससे आपको पता चल जाएगा आपका मॉडल ओवरफिट हो रहा है या अंडरफिट हो रहा है या ऑप्टिमल फिटिंग है, ठीक है। कूल, तो अभी आज के लिए यहीं पे स्टॉप करते हैं। आप बताओ इसमें से कौन सा चीज समझ में नहीं आया। 10 स्पेसिफिक नहीं है, 10 यूजुअली हम यूज करते हैं, यू कैन डू 20 आल्सो। या सॉरी,
के फोल्ड क्रॉस वैलिडेशन में जो सर आपने बताया the bias, once we will get the bias, then we will define it's under fitting or what. Same rule will apply 10%?
Same rule. बस bias और variance calculate करने का method अलग है.
Okay.
Rule same. Variance of 10 numbers. 10 numbers है ना आपके पास, तो 10 का average ले लो bias, 10 का variance ले लो variance. ठीक है. हाँ variance का जो formula है, value minus mean to the power 2 उसका average फिर बस square root नहीं, उसको average है.
Can you please tell how to calculate the bias and the variance again?
Bias is average of the errors, variance is variance of the error. अभी ये मत पूछना variance कैसे calculate करता हूँ.
I have a question.
Yeah. What is your question?
Sir, when do we need to test all the models and compare the bias and variance to test which one is working well all the time?
Yes.
Okay.
You have to test this for every model. 10 numbers, ना? हाँ, 10 iterations होंगे ना इसके, तो 10 iteration के लिए नहीं, ये टेस्टिंग एरर कैलकुलेट करोगे आप. 9 पे बनाया, 10वां पे टेस्टिंग एरर कैलकुलेट किया, यहाँ पे 2 to 10 पे बनाया, 1 पे टेस्टिंग एरर कैलकुलेट किया. सिमिलरली ऐसे 10 एरर्स मिलेंगे ना आपको, तो 10 एरर का एवरेज ले लोगे तो बायस मिल गया, वेरिएंस ले लोगे तो वेरिएंस मिल गया.
वेरिएंस सबका लेना है 10 नंबर का पूरा.
Okay, so we'll close the class today. Any question before we do? हाँ, वेरिएंस 10 एरर निकलेगा ना, 10 एरर का एवरेज ले लिया तो बायस, वेरिएंस ले लिया तो वेरिएंस. Okay, any question? हाँ, ना 10 लोगे तो 10 एरर आएंगे, 20 लोगे तो 20 एरर आएगा. वैल्यू उस पर डिपेंड नहीं करेगा. Yes. Any question? No question. Okay, so let's close the class and I will see you guys next week.